Okay, six years wanted to run through corrections from the work that I posted to you yesterday. So the questions were questions 1 to 5 from page 219 of your textbook. So I've got run through each of those. So let's start off. Question 1 was asking you to identify which parts of the numbers that were given to you, the complex numbers, which part was real and which part was imaginary. So it's given to you in two parts, as you can see, and I've just done one as an example. We've got half and minus 3 over 2i. So all you're being expected to recognise is which is the real part and which is the imaginary part. And as I've written there, the imaginary part is the bit that's attached to I. But for the instance here, all I gotta do is you have to say what the real part is. The real part of the complex number is the half, and the imaginary part of the complex number, is the bit that's attached to the I. So it's the minus 3 over 2. Got to keep the sign, but we don't keep the letter, okay? Because I represents the imaginary section. So the value of the imaginary part is minus 3 over 2, if you want to think about it like that. Question 2 then, plotting on the Angran diagram. As we said, we've done these from the mock exam corrections, and we did a couple of other exam paper questions that tie in plotting the points. So I just wanted to do this on the page and show you. It's exactly the same as what you would do on an XY plane, as I've mentioned there. But instead of having X axis, we've got the real axis, and instead of having the Y axis, we've got the imaginary axis. So that's the only difference. The same process is the way we do it. You can see I've got the points 2, 3 over here. I'm just going to rewrite them over here. Points 2, 3, and minus 1, minus 1. And you remember that the order that we put them in, X, Y, X, Y. So I can plot those. I start at my origin all the time. I start at 0, 0. And what I do is I go across the x-axis till I find the number that I'm using. So I'm looking at the point 2, 3 now to start off with. So I start at 0, 0. I'll go across to 2. And then I go up to 3 on the y-axis. So imagine I go across to 2 and then up to 3. And then I plot my point there. So I'll get rid of them and I'll show you where it should be. So the point 2, 3 is, sorry, just trying to be as accurate as I can. The point 2, 3 is about there on your graph. And usually we draw a dot and a little circle around it. I'm trying to be as accurate as I can here, but it's a bit tricky using the stylus. Then the next one is minus 1, minus 1. So again, I start at my origin in there, and I go across on the x-axis to minus 1, and then I go down on the y-axis to minus 1. And I see that point, again, is about there. Okay, that's the best I can do, I think, lads. So that's our point. Again, we draw a dot and a little circle around it. Same process for the Angran diagram. I've got my real part, my imaginary part, real, imaginary. So just think of it as exactly the same as what we've done there with the x and the y axis, except we're talking about the real, the imaginary. Our real axis is the same as the x axis, and our imaginary axis is the same as the y axis. So that makes it even easier again, because I know when I've got 3 plus 2i, I've got the real, the imaginary, the x, the y, exactly the same, okay? 2 minus 3i, the real, the imaginary, the x axis, the y axis. So exactly the same. So I take my 3 on the real axis, I go across, again I start at the origin, I go across the 3, and then I've got plus 2i. I'll circle it with the sign in there because the sign is important, the plus 2i. So when it's positive, I'm going up, and when I'm negative, I'm going downwards. So I've got across the 3 on the real and then up to 2i, and that will give me my point about there. Okay. And then for the next one, 2 minus 3i, I take the 2 to start off. I go across to plus 2, and then I go down to minus 3i. So across to 2 on the real, down to minus 3i in the imaginary, and that's approximately there. And as I said, I'm being as accurate as I can, lads, but it's not perfect. There, that's probably the best I can do. Alright, so that's plotting those points, and usually you'd name them. They'd be named, or you could write what's beside them. So for example, you could write 2 minus 3i there, just so you know what that point is. Okay, so that's question 2 done. I've done 2 examples there. Hopefully you'll be able to follow that to use the rest. The next one then, question 3, all we're being asked to do is the same thing, to plot them. But you might be thrown off because they're just individual numbers here. So you got minus 2, 3i, 4, and so on. You have to think about this like you would be given a plotted point on the XY axis. Again, imagine it was 0, 2, or minus 3, 0. You have to think about it like that. So part 1 you can see is minus 2. There's no imaginary part. It's only the real part. So your point is going to be on the real axis. It's going to be on the real axis. So you can imagine it. It's minus 2. The imaginary part is 0 essentially. So it looks like you're thinking of it in terms of part 5 there. 2 plus 0i. So this is minus 2 plus 0i. So you can imagine I go across to minus 2, but then I've no imaginary part, so I don't go up or I don't go down. I stay on the real axis, and my point is there, as close as I can get. Okay, so that's my point, minus 2. The same idea, 3i has no real part, so I'm not going across the real axis. I'm just going up on the imaginary axis, up to there, up to that point. 3i is up there. 4, same idea, no imaginary part, so I'm staying on the real axis, and my point is there. Minus 5i, again, no real part, so I'm just on the imaginary axis, and I'm going all the way down to minus 5i. 2 plus 0i, same idea. I'm going across the 2, and then I don't have to go up and down on the imaginary part, so part 5 is there. On the line as tight as you can, and then I on its own, again, no real part, so just up to 1i, or I on its own, and you plot like that. Nice and straightforward, I hope. So have a look back over those and see where I'm plotting them and why I've plotted them that way.